Okay, the first part of practice now then basically just require you to sum up the volume of the cylinder, the volume of the cone equated to 60, which is given in the question, and very simple, just have to make H the subject. But now, the second part, you are supposed to show the total surface area of the container. It is comprising of the cylinder, so the curved body is 2 pi RH. How to find the curve of the cone itself? What's the formula? Pi r L. But L is this L over here. Do you know what is L? How? You have to make use of Pythagoras theorem because this is a right angle triangle. So L is equal to square root of 2r bracket square plus r square. Am I right? Pythagoras theorem, So this will be square root of 5r square. If you really want to simplify this will be square root 5 times r. So I'm going to plug in everything. Why? Because your subject, everything is in terms of r. So now, if I don't want h, what to do? Use the one on top. The L is already given here. And your job is to simplify everything until it looks like the form that is given in the question. Will it look like that form? It will look like that form. Do I need to expand everything for you? If you can't see, you multiply term by term inside. I'll do very quickly. 2 pi r times 60 will be 120 pi r. Am I right? You reduce to lowest term, this will be 120 over r. Likewise, 2 pi r times r, 2 third r, negative 4 over 3 pi r squared. Agree? This one, simplify, this is square root 5 pi r squared. See? But Mr. Liu, it looks different from the form. How to simplify? It's not simplify. It's like 120 over r plus 2 pi. No, you need to factorize the r squared. Alright? It's not called simplify, it's called factorize. Take out the common term r squared. And you have exactly the form. Shown. Class. This part, if you cannot do, I really won't force you. But I encourage you. The key thing is part 3. That is the important one. Okay, part 3 is the one. What did they ask? Find the value of r for which a is stationary. Giving your answer correct to 1 decimal place. What should we do now? Stationary. What should we do? Anyone? Yes, differentiate a with respect to? With respect to? R. But do you differentiate immediately? Do you differentiate this immediately? No. Please don't. Simplify first. Okay, all look here first. Don't copy, How do we simplify? Can we simplify 120 over r? How? Agree? Do we need to simplify this one? This is the trick. Some of you will open up, but no need. Look here. What are these? Are these numbers? Is pi a number? Yes. So this whole thing is a number. Of course, you can multiply out, you still get the same result. But if this whole thing is a number, I just have to differentiate this one and bring the number in front. Am I right? So now, you told me differentiate a with respect to r. How do I differentiate this? Agree? All agree? I didn't do anything special. I just differentiate. Bring down the power, reduce the power by 1. Chen Ming, correct? Okay, what do we do next? No, not so fast. After you equate, after you find the first derivative, you always equate to 0. Okay, now comes the part where you have difficulty. How to solve for R? This is the part. Anyone? Let me tell you, I want a fraction on one side, then after that you cross multiply. Always have fraction on one side. Can we cross multiply now? Realize the R square can multiply over here to get an R cube. I write wrongly. Oh, the 2 is on the outside. Thank you. Okay, I'm doing very quickly. R square multiplied by R will give us an R cube. Am I right? But I would like to divide all the numbers over here. I'm going to press the calculator first. But Mr. Lee, you say cannot write fraction within a fraction. This is working. This is not the final answer. How to find R? Cube root of this answer over here. Okay? You realize it's not as easy as the previous one. Yes. So far okay? Okay, I know the solving down here looks kind of difficult. Tell yourself, I want the unknown to one side, I want the numbers on the other side before you can find the answer, and then press the calculator to correct to 1 decimal place. Okay? Now, is this done? Is this done? You press the answer. But are we done? What else must we continue doing? Determine whether the stationary value A is maximum or minimum. How? How to determine whether is it maximum or minimum? How? Class, look here. There are 2 ways. How to determine whether is it maximum or minimum? There are 2 methods. There's the box method, that is the second derivative. Do you want to use the box method or the second derivative? Okay, let's do the second. Quick one. This one will become positive 240. R to the power of negative 3. This one, when you differentiate, is only left with a constant. Am I right? This is R to the power of 1. Your guess is as good as mine. Why? This will always be positive because the radius is positive. This will always be positive. Am I right? This is greater than 0. If this is greater than 0, what are you concluding? Minimum what? Not point, Minimum what? Not minimum value. Minimum what? Minimum area. I drew the bracket here just now. The numerator, minimum area. And check the last part again. Hence, the stationary value. The stationary value has been concluded to be minimum area already. Now find the minimum area. How to find this minimum area? Substitute this value of R inside where? The area formula. Okay?